Okay, this is problem 84 from chapter 6. It's a little bit of a longer one, but anyway, the initial problem is we have birds that, well, let me read it a little bit actually. All birds, independent of their size, must maintain a power output of 10 to 25 watts per kilogram of body mass in order to fly by flapping their wings. So we're given that we have this bird that's 70 grams, which I just converted to 0.07 kilograms. And it's asking us, this hummingbird that weighs this much, it flaps its wings 10 times per second while hovering. And it wants us to estimate the amount of work done by such a hummingbird in each winged beat. So our range of energy, because they need to flap 10 to 25 watts per kilogram, we have our energy range is 0.07 to 1.75 joules per second. So to find the work done per beat, the range is what we're finding. So we're going to take that 0.7 and divide it by 10 beats, because they're doing 10 beats per second. And that's just going to give us 0.07 joules per beat. And then we'll solve for the other one, which is just using the 1.75 joules per second divided by 10 beats. That gives us 0.175 joules per beat. So this is the range. Is that all they wanted for that one? Let me check. Yeah, by each wing beat. So each wing beat, it has to produce between 0.07 joules per beat to 0.175 joules per beat in order to maintain flight. I think that's what it's asking. So that's the first part. The next part, I'll read it so we can explain it better. So we have a 70 kilogram athlete can maintain a power output of 1.4 kilowatts or 1400 watts for no more than a few seconds. The steady power output of a typical athlete is only 500 watts or so. Is it possible for a human-powered aircraft to fly for extended periods by flapping its wings? So, we're given that this 1400 watts, but it says if they are, a typical athlete is only capable of outputting 500 watts or so. So at 70 kilograms, that's what we're looking at here. We have a 70 kilogram athlete. You would need to maintain 70 times 10 watts, which is 700 watts of power to maintain flight. So 500 watts wouldn't be enough in order to do that. So I'll explain this. So we have a 70 kilogram athlete. He would need to do that times 10, so 700 watts. But if the average athlete can only do 500 watts from what it's saying here, then that's not enough to fly. If they were outputting this 1400 watts, then you might be able to do, well, you probably would fly a little bit, but probably not very far or very long with the 1400 watts. You need quite a bit of power in order to do that. So that's part B. So the answer to part B is, it asks, is it possible for a human-powered aircraft to fly for extended periods of time by flapping its wings? Not at the power that they're giving. It would have to be a lot more powerful than 500 watts.